After resistivity, now we shift to the topic effect of temperature on resistance. What is the effect of temperature on resistance? Similar to resistivity, in case of resistance also, we classify the substances into three categories. The very first is what? Conductor. Effect of temperature on resistance of a conductor. Consider a conductor having resistance R1 at temperature what? T1. Resistance R2 at temperature what? T2. At temperature T1, the resistance is what? R1. At temperature T2, the resistance is R2. T2 is greater than T1. Therefore, we can write change in resistance is equal to what we can write? R2 minus R1. Change in temperature is equal to what? T2 minus T1. So at temperature T1 the resistance is R1. At any higher temperature T2 the resistance is R2. So change in resistance is what? R2 minus R1. And change in temperature is T2 minus T1. Experiments show that change in resistance is directly proportional to initial resistance as well as change in temperature. It is experimental observation that resistance increase is directly proportional to initial resistance as well as change in temperature. That is the experimental observation. To remove the proportionality sign, we introduce a constant, that is R2 minus R1 is equal to R1 T2 minus T1. This is alpha and it is called temperature coefficient of what? Resistance. Alpha is proportionality constant and it is called temperature coefficient of resistance. Therefore, alpha is equal to R2 minus R1 students upon R1 into what? T2 minus. So alpha is equal to R2 minus R1 upon R1 into T2 minus T1. Let T2 minus T1 is equal to 1 degree Celsius. Therefore, alpha is equal to what? R2 minus R1 upon what? R1. Let T2 minus T1 is equal to 1 degree Celsius. Again we can write that alpha is equal to R2 minus R1 upon R1 when if T2 minus T1 is equal to what? 1 degree Celsius. Alpha is equal to R2 minus R1 upon R1 when T2 minus T1 is equal to what? 1 degree Celsius. That is temperature coefficient of resistance is defined as ratio of change in resistance to original resistance when temperature is increased by 1 degree. It is defined as the ratio of change in resistance to original resistance when temperature is increased by 1 degree Celsius. SI unit. Students, the unit of resistance will cancel out with resistance. So it will be left unit of temperature. So its SI unit is degree Celsius power minus 1 or Kelvin power. So this is the SI unit, Kelvin power minus 1. Again, we can write R2 minus R1 is equal to alpha R1 T2 minus T1. Take R1 that side. So R2 is equal to R1 is common. You will write 1 plus alpha. So with the help of this formula, you can calculate the resistance of given conductor at any higher temperature if you know its resistance at any lower temperature. R2 means resistance at higher temperature is equal to R1 1 plus alpha T2 minus T1. Let T1 is equal to 0 degree Celsius and R1 is equal to R0. T2 is equal to T degree Celsius and R2 is equal to RT. Then this equation will become RT is equal to R0 into 1 plus what? Alpha T. So this is the relation when the resistance is given at 0 degree Celsius and T degree Celsius. So in this way, dear students, we see that in case of conductor, resistance increases with increase in temperature. In case of alloys we say no change. In case of alloys, there is no change in resistance with temperature. The third one is what? Semiconductor. So in case of semiconductor, resistance decreases with increase in temperature. Keep in mind, in case of semiconductor, resistance decreases with increase in temperature. For semiconductors, the value of alpha is negative. In case of conductors, alpha is positive. In case of semiconductors, alpha is negative. So in semiconductor, resistance decreases with increase in temperature. The value of alpha in semiconductors is negative. Therefore, what will be the equation? R2 is equal to R1 into 1 minus what? Alpha into what? T2 minus T1, or RT is equal to R0 1 minus alpha T. So remember very well that alpha for conductor is greater than alpha for alloy is greater than alpha for what? Semiconductor. The value of alpha is maximum for conductors, then alloy, and minimum is for what? Semiconductors. So coefficient, temperature coefficient of resistance is maximum for conductor and minimum for semiconductor.